I'm going to work through an example of the comprehensive um, gateway exam, even though this really is just randomly selected problems from the previous 4 gateways. So if there's a type of problem that you're not sure about, going back to look at the other videos for the previous 4 gateways will give you yet another example of these problems. So I'll work through these fairly quickly, knowing that you can go back and look at more examples if you want. The first problems are just making sure we're okay with fraction rules and evaluation. Um, so the rule for multiplying fractions is multiply the numerator, multiply the denominator. So the denominator here is 3 times 11. The reason I write it like that is because I want to check to see if I have a common multiplicative factor before I bother multiplying it out. It's sort of at cross purposes to multiply something out and then try to factor it. So notice that 6 does have a multiplicative factor of 3, and the denominator has a multiplicative factor of 3. And so multiplicative factors only in the numerator and denominator can cancel out, and so 2/11ths will be my answer. Evaluating the expression is just being careful about putting the numbers into your calculator, so I'll just do the arithmetic as much as possible in my head that I can do. So 4 times 7 is 28. I'll go ahead and do that. Y is 7 minus 3. So first thing you want to do is change the expression into something with numbers in it, and then make sure you don't get out of line with your rules. The 28 minus 6 is 22. 7 minus 3 is 4. There is a common multiplicative factor between these two, namely 11. 22 is 2 times 11, and 4 is 2 times 2. So common multiplicative factors cancel out, and we have 11 halves as the simplified answer. This is the same sort of problem, but using algebra rules. So don't forget that we want to keep everything separated. I want to do my simplification of the numerator, my simplification of the denominator, and see what happens. So distributive property first, 15 times x, 15 times 5, 75. The subtraction has to be distributed across the parentheses as well, so minus 15x and minus 7. So all of that's in the numerator. Make my fraction bar go all the way across, so I'm sure I keep all of that stuff together. X plus 5 is the denominator. So the numerator here simplifies just because we have 15 times x minus 15 times x. So that amounts to 0. 75 minus 7 is 68. So I'll have 68 in the numerator and x plus 5 in the denominator. So it's just a matter of being careful with your algebra, and you can see that letter C here is that expression. Finding the equation of a line. This is important in all future classes that you'll take along the lines of calculus, so we should be able to do this quickly and easily. I use point slope form just because it's very simple and I don't have to hope for different things to be given to me. So for point slope form, the initial form I would have is this. At y minus 2, that's y minus the y coordinate I'm given, is 6, the slope, times x minus the x coordinate I'm given. So x minus minus 15 is x plus 15. Very easy to check that this is right, because if you put in this point, you put y equals 2 here, you'll get 0 on this side. You put x equals negative 15 here, you get 0 on this side. So the equation will say 0 equals 6 times 0 at the point, and that's what will always happen with point slope form. Now the question says to put this in slope-intercept form, so that means I will manipulate this equation until I have the y by itself on one side. So I'll distribute on the right side. 6 times 15 is 90. I'll add 2 to both sides. I'll put it in the answer blank here. Y equals 6x plus 92. Graphing a line should be simple because 2 points determine a line. So even if you have no idea what else you're doing, just plot 2 points. You might want to plot 3 just to make sure you don't screw one of them up. Obviously, if you plot 3 points and they don't look like they fall in a line, then you've made a mistake. One easy point to plot is always where x equals 0, because that's easy to plug in. The equation says y equals negative 3 halves 0 plus 1, so that means y equals 1. That's our y-intercept. One reason we highlight the y-intercept is because it's a super easy thing to plot. It's always what we plot by plugging 0 in for x. And it has nothing to do with whether it's a line or some other function. The y-intercept is always easy to find. Other numbers that would be easy to plug in, well, if I don't like fractions, plugging in an even number for x would be good because that will make this part a whole number. So if I use 2 for x, then the equation, I'll write this out. It says y is negative 3 halves of 2 plus 1. So this is negative 3 plus 1 is negative 2. So when x is 2, y is negative 2. And then just for good measure, let's see what happens when x is 4. Here I'll have negative 3 halves of 4, which is negative 6, plus 1 is negative 5. So I'll plot 3 points just to make sure. 0, 1 is here. 2, negative 2 is here. And 4, negative 5 is here. So it does look like those fall on a nice straight line. So I'll cheat and use a straight edge tool. So the line will look like that. And it extends in both directions. Slope of the line between 2 points, this is just rise over run, so this is just a matter of being careful with the arithmetic. A lot of people try to do this in their head, so I would strongly recommend just writing out exactly what you're doing. So the change in y, 5 minus negative 9, change in x is 6 minus negative 1, just literally the subtraction of the y's divided by the subtraction of the x's. So 14 on top, 7 on the bottom, so 14 over 7 is 2. The key to these graph problems is to realize that when you have an equation like this, that is saying that on the graph, I want to know when the y-coordinate is negative 8. Right? In this f of x notation, the x-coordinate is the number you're putting inside, so that's the x-coordinate. The f of x represents the y-coordinate. So if you have a question like this, you just have to determine, is it asking you for, is it giving you an x and asking you for a y, or is it giving you a y and asking you for an x? And so what's happening here is it's telling you that the y-coordinate should be negative 8, and it's asking how many times that happens, how many x's does that happen. So the y-axis is this one. So the y-coordinate of negative 8 is here, and you can see that there's a point right here. That's the point negative 2, negative 8. So that's a point that has a y-coordinate of negative 8, and there's another point, 8, negative 8. So not only do I know how many times it happens, I can tell you exactly where it happens. So this point means that f of negative 2 equals negative 8. And this point being on the graph means that f of 8 equals negative 8. So that's answering more than is being asked, but I can definitely tell that there are 2 times where we get a y-coordinate of negative 8. This is actually the same problem with a different function. Notice again, it's just randomly generated, so this is a coincidence, but they're asking about how does the y-coordinate ever get to be negative 8? And the y-coordinate is the output of this graph. So f of x should equal, this expression for f of x should equal negative 8. And it's asking what x's will do that. So in other words, this problem is asking us to solve the equation x squared minus 7x minus 52, because that's the formula for the y-coordinates. We want to know when that's equal to negative 8. And so because this is quadratic, our strategy is get 0 by itself on one side. So if I'm going to add the 8 to both sides, like that, and I try to factor. I hope it factors. If it doesn't, then I have to use the quadratic formula. But there are two numbers that multiply to be 44, whose difference is 7, and that's 11 and 7. So if you use minus 11 and plus 7, it's easy to check. I'm sorry, plus 4. So two numbers that multiply together to be 44, or 11 and 4, and their difference is 7. So you can check this with FOIL to make sure this is right. But that means that x equals 11 or x equals negative 4. So that's the answer that I would write in this blank.